Hey everyone, welcome back to another video by Camroom 5. In today's video we're going to be talking about the drawing of correct tables, which is an important part of the A-level P3 exam. So drawing correct tables to record the data is an important part of the P3 of AS level exam, which is the advanced practical skills. The first kind of tables we need is in volumetric titration, where we are dealing with the concentrations and volumes of various aqueous solutions. Then we have gravimetric, where we are dealing with the mass and measurements of crucibles. Then we have thermometric titrations, where we are dealing with the temperature changes in aqueous solutions mostly. Then there are experiments related to rates of reactions, and then the most favorite is qualitative analysis. So let's begin. When we talk about drawing the correct tables for proper recording of our data, there are a few things that we have to keep in mind. So things to keep in mind while we are making the tables. Number one is going to be that you have to make your table with ruled lines. They should be with pencil and properly made using a ruler. The second is that you have to be placing correct headings plus their units. What kind of headings we place in the table depends on the kind of information, and we'll talk about that. The third point to keep in mind is correct decimal places based on the accuracy and the precision of the apparatus. So based on the accuracy and precision of the apparatus, they could be 2 decimal places, 1 decimal place, or no decimal place at all. Then another important thing is correct recording, which we already know, and determination or calculation. Now you might ask, what's determination or calculation? Because we're already measuring the values. See, we'll talk about it because sometimes we have to manipulate the data also. So keep that in mind. Let's talk about the first kind of table, which is volumetric titration, where we are dealing with the aqueous solutions, their volumes, and their concentrations. So let me draw a hypothetical table for you guys. While we draw the table with ruled lines, we need to place proper headings on that also. So for volumetric titration, the headings are going to be initial burette reading, and then we place a slash, and then we place the units, which are obviously centimeter cube. Make sure you can't write just, VOL for volume. It's not much appreciated. You might get a mark for it, but there are chances that they might ignore it and not give you a mark. The second row is generally final burette reading. Again, we place a slash afterwards, and then we place the unit, which is centimeter cube. Another important thing to keep in mind is don't write INI or FIN for initial and final. Just put in some effort, write the proper words, write entire thing. The final row is going to be volume of, hypothetically, let's call it FA3, so volume of FA3 used slash centimeter cube. Centimeter cube is the unit, and you need to write the proper units for every heading. Even if you miss it once, you would be penalized for it. Now I'm going to divide the remaining working space into 4 different columns. Generally, we're expected to perform first rough titration, which is just an estimate, to have an estimate to approximate how much volume is needed, and then we have fair titrations. When you're putting the values for titration, don't forget to put your values till 2 decimal places, because that is the accuracy of the burette. So 2 decimal places in all burette reading is a compulsory. It's very important. Because burettes are accurate to 0.05 centimeter cube, which means you can measure 0.05 minimum volume from it. So your last decimal place is equals to 0 or 5 decimeter cube. Even if you miss the 2 decimal place thingy once, you get penalized again. Then for the other titrations, for example, the first correct titration and the second correct titration, your values are written. For example, these are hypothetical values. you subtract these values and you get the volume of blah 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 used. See, you can see my values are at a difference of 0.10 centimeter cube, right? These are called concordant readings, which mean a difference of 0.10 centimeter cube between two readings. So we don't need a third fair titration because my first and second were already concordant. Now let's move on to another kind of experiment where we have gravimetric analysis. When we talk about gravimetric analysis, we are dealing with the measurements of masses. So for example, we might be dealing with decomposition of a solid. We might be dealing with making the loss of water of crystallization, things like that. So all of the gravimetric analysis rows have the phrase mass in the beginning because this is what we are measuring, unless the examiner asks for something else. For example, the first row is going to be mass of empty crucible and lid slash the units, which is grams. Since you're placing the lid on top of the crucible, you need to talk about that. For example, another heading could be the mass of crucible and lid and Fa3. Fa3 is again an example. Whatever label is there, place it there. Since Fa3 is obviously a solid because that's why you're measuring the mass, you can call it the solid. That's okay. You can call it the contents. That's okay. Make sure if you're placing the lid on top of the crucible while you're making the measurements, you talk about it. You have to be consistent with lid. You can't mention lid in few rows and not mention it in the other ones because then it means that you were not placing it. Units are important. So if it's grams, obviously, you have to place the unit after every heading with a slash. Generally, we place the third row is going to be the mass of Fa3, which is the subtracted mass from the one in the beginning. I missed it here, but you need to keep that in mind. For example, if you're heating the substance, your heading could be mass of crucible and lid and residue after first heating / grams. Now you might ask me, why am I calling it residue and not Fa3? We call it residue after heating because during heating there is definitely some kind of chemical changes. Maybe loss of water of crystallization, maybe thermal decomposition, something like that. So you need to talk about calling it residue and not the original label. If your question wanted to heat the substance twice, then maybe you can say mass of crucible, lid and residue after second heating. Because now you're implying that you heated it first, you allowed it to cool, and then you heated it again. So talk about that. Generally, when we are done heating, we place it to cool, right? So when it's cooling, only then you measure the mass again. So maybe the other two rows can be the mass of residue after first heating, the mass of residue after second heating, things like that. Calling it residue is really significant because you can't call it the original label after heating. After heating, you call it residue only. So maybe the next heading could be mass of residue after second heating. You can place mass of residue after first heating also. That would be also important. Another example of a heading could be the mass lost. So if you were having a mass of, let's suppose the contents were 10.00 grams in the beginning, and now after heating, let's suppose it was 9.00 grams. Talk about mass lost. Oops. Okay, I'm here. Yeah. So moving on, your mass balances are generally accurate to 0.01 grams. So 2 decimal places are very imperative over here. 2 decimal places in an electronic mass balance are a must, because your balances have an accuracy of 0.01 grams. Their second decimal place can be any integer. So it's not limited to 5 or 0 like burette, it is any decimal place. And then you place all the mass values with 2 decimal places. You don't have to write the grams because since your heading already has it. So these are things that you need to keep in mind while you are placing the table for gravimetric analysis. Another thing to keep in mind, I'm placing it over here, is make a new row for mass of residue after first heating. Maybe another heading for mass of Fe3, which was also important, / grams. So based on your question and important things, you need to decide what headings are there. Don't compromise on that. I hope these ideas are clear. Now we can move on to another rate experiment. I'm reading the question which says you're to investigate how the rate of reaction between acidified hydrogen peroxide and aqueous iodide ions depend on the concentration of hydrogen peroxide. I'm not reading the whole question. We know that it's a rate of reaction question where you have hydrogen peroxide and iodide ions. You can see the equation, you can see the label of the chemicals. Fb1 is hydrogen peroxide, Fb2 is potassium iodide, Fb3 is sodium thiosulfate, and Fb4 is sulfuric acid. I want you to pause if you wish and read the procedure thoroughly. I'm reading it very quickly. It's fill a burette with Fb3. Fb3 was the sodium thiosulfate, so burette is going to be having sodium thiosulfate. Use the measuring cylinder labeled A to place 25 cm cube of Fb2, which was potassium iodide, and 25 centimeter cube of distilled water into a conical flask. I'm just reading it. You can pause it if you wish to read it more slowly. Then it said 10.00 centimeter cube of Fb3 from the burette and 6 drops of starch indicator into the conical flask, obviously. Then it says measuring cylinder B to place 50 centimeter cube of Fb1 and 20 centimeter cube of Fb4 into a 100 centimeter cube beaker. Since they're using multiple apparatuses, I would like you to have a clear picture of which two apparatus are being used. The first is a conical flask, and another is a 100 centimeter cube beaker. What are they placing in the conical flask? The second bullet tells you that you are placing 25 centimeter cube of Fb2 and 25 centimeter cube of distilled water in the same conical flask. Another thing that you guys are placing within the same conical flask can be seen in the third bullet point, which is 10.00 centimeter cube of Fb3. You need to understand that since it's from a burette, that's why I am placing 2 decimal places, right? The beaker is going to be having 50 centimeter cube of Fb1 and 20 centimeter cube of Fb4. These are 2 separate pieces of apparatus, and they are not mixed yet, but they will be mixed soon. Because your fifth bullet says pour the mixture from beaker into the conical flask. You can understand how the conical flask has a total volume of 60 centimeter cube and the beaker has 70 centimeter cube. When you mix them, they will inshallah be 130 centimeter cube, right? Because when you're pouring the mixture from the beaker into the conical flask, you're mixing them and the total volume is going to be becoming 130 centimeter cube. And then obviously you time it out. Another thing to keep in mind is whenever you are timing an experiment, they are to nearest second. Now record in the table on page 4 the reaction time in seconds to the nearest second, like I just said. Nearest second means whole number. You don't have to place the milliseconds, you don't have to place any decimal points because the question is very explicit. Now let's read experiment 2. Experiment 2 again has the conical flask and the 100 centimeter cube beaker. It's very important to understand what are we placing in which apparatus so we can place the proper table. Like 25 centimeter cube of Fb2, and this time you have 35 centimeter cube of distilled water. You can realize I have increased the volume of distilled water. I'm also placing 10.00 centimeter cube of Fb3 from burette and obviously these 6 drops of starch. Why am I placing more water here? Now that doesn't make sense so far. This is only because in the beaker I'm going to be placing 40 centimeter cube of Fb1 instead of 50. The 20 centimeter cube of Fb4 is still the same. I want you to understand how this time the conical flask and the beaker both have different volumes compared to last time. The conical flask has 70 centimeter cube and the beaker this time has 60 centimeter cube. If you compare it from experiment 1, you can realize that last time the conical flask was at 60 centimeter cube, but this time it's 70 centimeter cube. Last time the beaker was at 70 centimeter cube and this time it's at 60 centimeter cube. You can see that, right? The beaker had more volume, but now it has less. But one thing is constant. Now what is that one thing? The total volume was 130 centimeter cube last time after pouring the beaker content into flask. This time it's also 130 centimeter cube. You're increasing water, but you're decreasing FB1. So FB1 volume is being decreased by 10 centimeter cube, but distilled water is being increased by the same amount of water volume. This is in order to keep the total volume same. The total volume was 130 centimeter cube last time. It is again 130 centimeter cube this time. Now let's understand how the table will be drawn. We have 5 different experiments. Your experiments 3 to 5 are in the same way, right? So what different chemicals am I using? I'm first placing the volume of FB1. I will place a slash and then centimeter cube. The second column is going to be volume of distilled water. And again, I'm going to place a slash and I'm going to place the units, which are centimeter cube. Then I have the volume of FB2, which is in the units of again centimeter cube. Then volume of FB4, again slash units. So FB1 distilled water, FB2, FB3, FB4. And then units each time. Then we were doing the reaction time. How we do it, I'll give you another video on that also. But reaction time is a unit of seconds, and then rate of reaction is generally calculated by dividing 1000 by the reaction time. So the unit for reaction time is 1000 second inverse, or you can write second inverse. Moving on. In the very first experiment, if you remember, how much FB1 was there? So if you notice, FB1 was at 50 centimeter cube. So I'm going to place 50 over here. No decimal places because it was measuring cylinder, not a burette. Then in reaction 2, it was 40 centimeter cube. You can realize how the volume of distilled water and FB1 are changed to keep the total volume same. Volume of FB1 was having no decimal places as it was measured using a measuring cylinder, as it is made using measuring cylinder which are not accurate pieces of apparatus. Another thing to keep in mind is how we'll keep the total volumes same. And generally an increment or decrement of 5 or 10 is very ideal. So my other experiments are going to involve the same volume of FB2, FB3, and FB4. Keep in mind how FB3 should have 2 decimal places, but others will not. Because FB3 was measured using a burette. So FB3 was measured using a burette. The others were measured using measuring cylinder. Let me write that. Using burette. So 2 decimal places are highly imperative over here. Now I can decrease the volume of FB1 from 40 to 30 to 25 to 20. I don't want to move the volume till 10 centimeter cube because that would be immensely less. Sometimes the question even says not to go till 10 centimeter cube. I will increase the volume of distilled water each time to make sure that the total volume is 75 each time. You can see that in the first experiment the total volume was 75 centimeter cube. In the second experiment, it's again 75 centimeter cube, and so on. So keep that in mind. Total volume is 75 centimeter cube from FB1 in distilled water. The other values are all the same because we are not changing the other volumes of chemicals. We are increasing the volume of water and decreasing the volume of FB1 so that the concentration of FB1 changes each time. When you measure the reaction time, make sure it's in whole numbers. There are no decimal places. Obviously, when you are decreasing the volume of FB1, the rate of reaction will slow down, so reaction time will increase, right? So I'm just putting hypothetical values. Whenever you find the rate of reaction, make sure that your time was in two significant figures. So rate of reaction is also good for 2 to 3 significant figures. Rate of reaction can be found by dividing 1000 by your time. It would be much appreciated if there are 2 to 3 significant figures. 1 is never acceptable, 5 is a little too much. So I hope this video is clear to you guys and you have gotten an idea of how to draw tables. Stay tuned guys. Thanks.